Subaccelerated variables of 2, stir up here. A, this is 6J. Long division and synthetic division. We've talked about this in some of the class times too. So when you see this kind of problem, you know that this is just 9 into 36, which goes 4 times, and you get 36, right? So your answer is 4. And then if you had to say 5 into 36, you might put a couple decimal places and say 5 goes into 36 7 times. 7 times 5 is 35. 1, bring down the 0. 5 goes in 10, so 7.2 would be your answer there. Okay, because then you get 10, 0. So we have divided two polynomials so far as synthetic division using substitution, things like that. All right, so let's take this one. So this is going to be what's going to be outside. An important thing to do when you're doing this is see I'm adding the x squared term as a 0. So that's important to do with these, okay? All right, so I have 3 numbers here, so I'm going to count 1, 2, 3. So I'm going to start putting my information here. Okay, so what times x squared gives me 2x to the 4th? And I'm always looking to the furthest left inside. So that would be 2x squared. So 2x squared times x squared is 2x to the 4th. 2x squared times negative 2x is negative 4x to the 3rd. And then 2x squared times 2 is going to give me 4x squared. And that's why you wanted to have that 0 up there. So now we're going to go ahead and subtract. So 2x to the 4th minus 2x to the 4th, they cancel out. 3x to the 3rd minus minus, so that's going to become plus. So 3x to the 3rd plus 4x to the 3rd is 7x to the 3rd. Make sure you see that sign change there. And then 0x squared minus 4x squared, so that's going to give me minus 4x squared. And then I'm going to bring down the 5x. And then we're going to start all over again. What times x squared gives me 7x to the 3rd? And it'd be positive 7x. So 7x times 7x squared is 7x to the 3rd. 7x times negative 2x is negative 14x squared. And 7x times 2 is 14x. And again, we're then going to go ahead and subtract. So 7x to the 3rd minus 7x to the 3rd, they cancel. That's going to give me a plus 14x. So negative 4x squared plus 14x squared is 10x squared. And then that's going to be minus 14x, so 5x minus 14x is minus 9x. And then bring down that last one. And then we're going to start over again. We're going to say, okay, what times x squared gives me 10x squared? And that would be positive 10. Positive 10 times x squared is 10x squared. 10 times negative 2x is negative 20x. And 10 times 2 is 20. And then we're going to go ahead and subtract again. So those cancel out. That's going to be plus 20x. So negative 9 plus 20x is 11x. And then that's going to be a minus 20. So negative 1 minus 20 is negative 21. There's no more to divide. So my answer is going to be what's on top plus, and I ran out of room, plus 11x minus 21 over x squared minus 2 plus 2. So you put it over your divisor. Okay? So this whole thing is the answer. And yeah, this plus should be down, with that. All right, so remember both polynomials must be in standard form to include and must include 0 coefficients. Also take care of the degree. The remainder must have a degree less than the divisor. Okay? All right, so if we try this one. So I'm going to go x squared plus 0x plus 5 is outside. Inside, I'm going to have x to the 3rd plus 8x squared minus 3x plus 16. I don't have any gaps, so I didn't have to put any extra zeros in other than right here. So I have 3 terms, so I'm going to come over to the 3rd term. What times x squared gives me x to the third? And that would be x. So x times x squared is x to the third. X times 0x is 0x squared. X times 5 is 5x. Okay, make sure we're subtracting. X squared minus x squared, those cancel. That's going to become a minus there, so that's 8x squared if I subtract that. And this becomes a negative 5, so that's a negative 8x. Bring down the 16, that's positive 16. Make sure to bring the sign. Do the same thing over again. What will I have to multiply times x squared to get 8x squared? Well, that'd be positive 8. 8 times x squared is 8x squared. Plus 0x plus 40, because 8 times 5 is 40. And we're going to go ahead and subtract. So those cancel. That leaves me negative x squared. And 16 minus 40 is negative 24, I believe. So my answer is going to be x plus 8 plus negative 8x minus 24 over x squared plus 5. You could put the 0x in it if you wanted to. But that whole thing's my answer. All right, so we have this. What is the quotient? What is the remainder? Okay, so the quotient's what's going to be on top. The remainder is what we left over with. So I'm going to go x minus 2 into 3x squared, or to the third, excuse me, minus 2x squared plus 2x minus 5. We have two terms I'm dividing by, so I come over to the second term. What times x gives me 3x to the third? And that'd be 3x squared. 3x squared times x is 3x to the third. 3x squared minus times negative 2 is negative 2, or negative 3x squared, excuse me. Subtract. So those cancel. That becomes a plus. So that's going to give me just x squared. Bring down the next term. Okay, what times x gives me x squared? It would be positive x. X times x is x squared. X times negative 2 is negative 2x. Go ahead and subtract. So those cancel. That gives me a 4x. Make sure to bring down the negative 5. Start over again. What are you going to multiply times x to get 4x? It'd be positive 4. So you get 4x minus 8. And we're going to subtract. So those cancel. That becomes a positive 8, so I get a 3. So what is the quotient? The quotient is 3x squared plus x plus 4. What is the remainder? The remainder is 3 over x minus 2. So that's over the divisor. Same function, but if we wanted to evaluate, so what I'm going to do is I'm going to take 2, and it's going to be our synthetic division. Make sure we don't have any gaps, so I have x to the third, x to the second, x, and no x. So remember, this first term comes down. 3 times 2 is 6. Add straight down, that gives me 4. 4 times 2 is 8. Add straight down, that gives me 10. 10 times 2 is 20. Add straight down, so that gives me 15. Okay, so the function at 2 is equal to 15. It is whatever our remainder is. So again, that would yield me the point 2 comma 15 if I wanted to plot it on a graph. All right. So dividing by x minus 2 has the same result as synthetic substitution for f at 2. And using the values on the bottom as the coefficients answer, we often refer to this process as synthetic division. So synthetic division is a pretty friendly thing to do once you get the gist of it down. Anything else to erase? Nope. Okay, if a polynomial is f of x is divided by x minus k, then the remainder is r equals fk, so we've already done that. And synthetic division only works for degree 1 divisors. So if you have x plus 2 that works, if you had x squared plus 7, it would not work if we did synthetic division. Okay, synthetic division. So I'm going to divide by 5, because you set that equal to 0. Put in I have 1, I have negative 5. I have to put a 0 in because I'm missing the x squared. 4, negative 17. So this comes straight down. 1 times 5 is 5. Add straight down. Those give me 0. 0 times 5 is 0. Add straight down. 0 times 5 is 0. Gives me 4. 4 times 5 is 20. Add straight down, so I get 3. So technically, this was x to the 4th, so you could rewrite this as x to the 3rd plus 0x squared plus 0x plus 4 plus 3 over x minus 5. You could write it that way, or you might be just looking like that. Okay, again, I'm going to set that equal to 0, so I'm going to divide by negative 3. I have a 1. I have a 0 because I don't have an x squared term. Minus 2 plus 12. Bring that 1 straight down. 1 times negative 3 is negative 3. Add straight down. That's negative 3. Negative 3 is 9. Add those up. So that gives me 7. 7 times negative 3 is negative 21. Add those. So that gives me negative 9. So that technically is my remainder. That would yield me the point negative 3 comma negative 9 as a point on our graph. If we wanted to write this, we could write it as 1x squared, or just x squared, minus 3x plus 7 minus 9 over x plus 3. So notice that's a degree less. That's 1 degree less right there. Okay, so that equals 0, so we're going to divide by 4. Excuse me. So that gives me a 2, a negative 7, a negative 1, and a negative 12. Bring that straight down. That's 2. 2 times 4 is 8. Add those. 1 times 4 is 4. Straight down. That gives me a 3. 3 times 4 is 12. Add those. Give a 0. That basically means that I have the point 4 comma 0. So that means that's a root. Okay, that's where it would cross the x-axis. We get the final value of 0 from synthetic substitution f of k. We know that x minus k is a factor of the polynomial. K factors mean it would be a root, meaning it would cross the x-axis. So a polynomial f of x is a factor of x minus k if and only if f at k is equal to 0. Okay, so that last term becomes 0 when synthetically divided. Okay, so we can use synthetic division when we factor. Okay, so if we knew this, this yields me x plus 5. Okay, that's what that would come to because it's equal to 0. So we'd have a part of this. So being that we know that, we can use synthetic division on this problem. So we have 1, negative 21, and 45. Bring the 1 straight down. 1 times negative 5. It's negative 6. That gives me 30. That's 9. 9 times 5 is negative 45. It gives me a 0. So we verified that. But now this is, if I put my x's back in, I'd get x squared minus 6x plus 9. We could factor that to be x minus 3 and x minus 3. And then we also know that we have that from above. So my entire thing factored would look like this. Okay, so we know that k equals 8. So we can just divide by this because it's already equal to it. So I got 1, negative 11, 14, and 80. No zeros in there. That's going to give me 8. And add those up. That's negative 3. That's negative 24. That gives me negative 10. That gives me negative 80. Bring that down. Gives me a 0. So I can put my x's back in here. So remember, this is going to be x minus 8 is one of the things, because you'd set that equal to 0 to get the 8. Factor this as well. Plus 2. And then we know that So that whole thing would be our above equation factored down. Remember that if negative 5 is a solution, then it is a factor. The factor is x plus 5, so which we just talked about up here. Okay? All right, so why don't you take a look at the 6J, and why don't you work on the odds? Okay, have a great day, everybody. Take care of one another. Bye-bye.